All right, we're graphing sine and cosine. And so we're going to use some of our, we're writing the equations of sine and cosine from a graph. So we're going to use some of the vocabulary we learned from last week, the amplitude, the period, the midline. And then we have a new one, the phase shift, which is just a horizontal shift. We're not going to focus on phase shift this week, so don't worry about it for now. Let's go ahead and look at what each of the features are. So the A is our amplitude, or our vertical stretch. The K is our midline, or our vertical shift, okay? The B value is our angular speed, which we get from the period. And the D value, actually the zero of the input, so when B times T minus D is equal to 0, and we solve for T, that's going to give us our phase displacement. Phase shift or phase displacement, same thing. Okay, so we're going to look at example number 1. We're going to look, I'm going to draw in my guidelines here. So I have the relative maximum at 1, relative minimum at 1, and I have my midline at 0. So I'm going to write that my midline, which I'll write as k is equal to 0. My amplitude is A, so I'm going to graph up 1 from my midline and down 1 from my midline, so my A is 1. The period, so I'm going to look low point to low point. I'm going to graph, it takes me 2 pi on the x-axis to graph my 1 full cycle. So the period is 2 pi, but the value I actually need is the B value. So I do 2 pi over B, and you solve for B. So I'm going to multiply B by both sides to cancel. I'm just going to do it under here. B times 2 pi is equal to 2 pi, and then divide by 2 pi, giving me 1. Okay, so B is equal to 1. And the phase shift, we're not going to worry about right now. Okay, so the next thing to do is figure out, do I have sine or do I have cosine? So a couple tricks are that sine starts at look at your x-axis, your y-axis. Does your graph start at the high point, the low point, or the midline? And it's actually going to start at the low point here. So a graph that starts at the midline is a sine graph. A graph that starts at the high point or the low point is going to be a cosine graph. Now, since we're starting at a relative min, this is a negative cosine graph. Okay, so I'm going to start my equation. Y is equal to A times the cosine of B times T minus D plus K. So next up is to fill in all my stuff. All right, so A is 1, except remember we had a negative cosine graph, so it's going to be negative 1 since we started on the relative minimum. Okay, times the cosine, B is 1, so I'm spinning at a normal speed, times T. We don't have a phase shift, so we don't worry about the D right now. And then plus, and my midline is 0, so I'm going to add 0. I'm just going to rewrite this as y is equal to negative cosine t. All right, on the units, if I were to draw a circle to figure out, remember cosine is the horizontal distances from 0. What this would look like is a circle that has a center point at 0, so midline at 0, and then an amplitude of 1, so that means a radius of 1, and it spins at 1 degree per second. That's it. Okay. All right. Next up. So we're going to look at, where does this graph start? High point. Oh, wait, let me graph in my midline and then my relative maximum and my boundary lines. Okay. Does your graph start on a high point, a midpoint, or a low point? It starts at a midpoint, so this is a sine graph. Okay, does it spin going up, or is the graph going down first? So from 0, it's going down. So this is going to be a negative sign. In other words, do I go to a relative minimum first or a relative maximum? We're going to a relative minimum, so this is going to be a negative sine graph. Okay, next up, amplitude. The distance from the midline to the relative max is 2 units. I'm going to check the other side. Okay, 2 units, yes. So the amplitude is equal to 2. The midline is at 0, so k is equal to 0. And the period is, let's see, I'm just going to count middle to middle this time. But the tricky thing about the middles is you have to count 3 of them, right? So that I go 1 full cycle, 1. Okay, so it looks like it takes us 2 pi. Takes us 2 pi to get around the circle, or I think 360 seconds. Okay, so 2 pi over b. When I solve for b, I get b is equal to 1. There is no phase shift in this example. Now we're going to write our equation. Y is equal to a times the sine of b times t minus d plus k. So y is equal to, my amplitude is 2, but it is negative, times the sine of, our b value is 1. So 1 times t, we don't have a phase displacement or a phase shift, and our k value is 0. So I get y is equal to negative 2 sine of t. All right, what does the circle look like? All right, this time the midline is at, we're focused on our height, so vertically, where are we on the circle? So my midline is still going to be at 0, 0. And then what I'm going to do is look at my amplitude. This time, the radius is 2. So it's a bigger circle. Okay. And how long will it take me to spin around the circle? It takes me 360 seconds. So it takes me 1 degree per second to spin around. That's it. All right, next. Okay, so do we start at the midline, the relative min, the relative max, or the midline? We start at the midline right here. Okay, at x equals 0, we are at halfway, the halfway point in our circle. Okay, so I see the midline is at 0. The amplitude is 1 unit, 1 unit from center. Okay, we're starting at the midline, so we have a sine graph. The period now, all right, I'm going to count mids. So 1, 2, 3. So it takes me, looks like it takes me pi seconds or 180 seconds to get around the circle. Okay, we're not going to focus on phase shift. So I'm just going to write it underneath. Okay, so pi is the period. And in order to get the number in the, so are we spinning faster or are we spinning slower than normal? Well, since pi is smaller than 2 pi, it's going to take us, we're walking faster than normal, okay? It takes us less time to complete a cycle, so we're actually going faster. So we need to solve for b. I'm going to go ahead and multiply b on both sides. And then We'll divide by pi. So b is equal to 2. So b is equal to 2. So I'm going to go ahead and write in my equation, y is equal to 1. So a times the sine of bt minus d plus k. So y is equal to 1 times the sine of 2t, we don't have a phase displacement, plus 0. So 2t. So this tells me, the 2 here tells me I'm spinning twice as fast as normal. So instead of spinning 1 degree per second, we're spinning 2 degrees per second. Sweet. Let's draw our circle. So sine again tells us about the height of my point on the circle. Okay. So radius of 1. You don't have to draw the circles. I am just giving you a picture of how it relates to the unit circle. Okay. And the midline is at 0. So the midline is at 0. And we are spinning 2 degrees per second instead of 1. Okay. So twice as fast as normal. All right. Here we go. Relative max, relative min, midline, looks like right here. Okay, I'm going to double check. From the midline up, I have 1, 2, 3, 4 units. From the midline down, I have 1, 2, 3, 4 units. It needs to be even. If it's not, you don't have the midline. Okay, so my amplitude is 4. My midline is at -2. The period, I'm going to start in the middle. Now I gotta do the lower part. Okay, it looks like it takes us 2 pi seconds, so that means 360 seconds. So the period is 2 pi. Remember, we have to get that b value though, which tells us how fast we're spinning. So a normal cosine graph or sine graph takes 2 pi seconds, 360 seconds to go around the circle. So when b is equal to 1, it's our normal speed. Okay, so the graph, are we starting at the mid, the high, or the low? Looks like we started at the mid, and then we went in the positive direction. So we have a positive sine graph. No phase displacement today. Okay, so I get y is equal to 4 times the sine of, my b value is 1, so 1 times t, no phase displacement, and then minus 2. Make sure you use the parentheses. Otherwise, if you put 4 sine of t minus 2, I don't know where that 2 belongs. Does it belong to the t, or does it belong after I do all of this stuff, basically 4 sine of t? Do I subtract it at the very end, or do I subtract it at the beginning? Okay, so no on that. Cool. What does this look like on the unit circle? Okay, this time what it's saying is that the midline is at -2 right here. That's the middle of our circle. And then we have an amplitude of 4, so it's going to be like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 2 minus 4 is -6. So, and then I'm spinning at a normal speed, 1 degree per second. So the highest, so if I'm a little like ant walking up this circle, the highest point that I'm going to get to is +2, and the lowest point I'm going to get to is -6. Is that what happens on the graph? Mm-hmm. Okay, very good. All right, next up, midline. I see it is at 1. Highest point, relative max at 2, relative min at 0. All right, so I have an amplitude of 1. Double check. Yup. Okay, so amplitude is 1. Midline is my k value at 1. The period, again, let's go mids because that's all that's shown. Okay, so it looks like it takes us 4 pi seconds to complete one cycle. So this time I'm going to write the period is 4 pi, and then so does it take us longer or less time than normal? Remember, normal is 2 pi. Like it takes us 4 pi seconds, so that's 720 seconds instead of 360. So are you walking twice as fast or half as fast? If it takes you longer, it's gonna be half as fast. Okay. To get the calculation, we do 2 pi divided by b. Multiply b by both sides. So I get 4 pi b is equal to 2 pi divided by 4 pi. I get b is equal to 1/2. So really this takes us, well, I'm like walking half as fast, so it's going to take me twice as long to get home, is what you can think. Okay. No phase displacement. Do we have a sine or a cosine graph? I have a sine graph. Are we going up first or down first? We're going up, so it's positive. I'm going to go ahead and write y is equal to the sine of 1/2 t, no phase displacement, plus 1. Okay, so that's what we got. What does it look like on the circle? Let us see. Sine is vertical, so the vertical midline is going to be at 1, right here, at 1. I have an amplitude of 1, so I'm going to go up 1, down 1, to the right 1. So I have a little circle right here. The highest value is 2. The lowest value is 0. How fast are we spinning? We're spinning half a degree per second. So half as fast as normal. Okay? All right. Okay, here we go. This one, high point, low point, midline. Okay, the mid is at 0. Amplitude is 4. Period is, I'm going to go, ooh, this one is tricky. This one has a phase displacement. Okay, we're going to stop there. Sweet.